Hello viewers, today's topic is block diagram of a computer system. So as all of us know, the computer system is actually a digital electronic device, and the components of a computer system are the following. So every computer system has central processing unit, which is called as CPU, right? So this is also called as a microprocessor. So you people might be familiar with the Intel microprocessors, AMD microprocessors and all these things. So this is actually the CPU, central processing unit. So central processing unit will be able to directly access the random access memory. So which is in short called as RAM. So this is also called as the main memory of the system. So CPU can read the data from the RAM, and also it can write the data from the RAM, write the data to the RAM. So both the read, this is actually a read write memory. So you can read the data as well as write the data to the RAM. And the other purpose of the CPU is it also accesses this input output processor, which is in short called as IOP. So what is the duty of this output processor is, so it communicates with your input output devices so that it synchronizes the operations of your input devices with your CPU. So it will read the data from your input device. So what are the input devices that we have? So the input devices are the devices like keyboard, mouse and so on, and the output devices like your monitor, projector and these things. So it communicates this with these input and output devices, and the data which is read from the input device is transferred to the CPU via this input output processor. And similarly, if the CPU wants to display or print some data to the printer or monitor, it communicates to the respective device through this input output processor only. So these are the major components. In summary, the first one is the central processing unit CPU, which is the essential part. So this executes all the instructions or the programs that are written by us. So what are the programs that are written by us are saved in the main memory, which is the random access memory, RAM. And finally, in order to read the data, we use the input devices, and to print the results of our computations, we use the output devices. So this computation, reading the data from the input devices and printing the results of computation to the output devices is done by the CPU with the help of a separate processor, which we call it as the input output processor, IOP. So this is a description of block diagram of a computer system. The next one is the definitions of these terms: computer organization, computer design and computer architecture. So what is computer organization? Computer organization is actually the way the hardware components operate. So for example, if there is a computer system, we'll be studying so what are these components are, how are they arranged, how these components communicate together to make the system working. Right, so that is what the definition says. So it is concerned with the way the hardware components operate, and the way they are connected together, they form a working computer system. So this is to investigate each and every component of the computer system so that and verify that all these parts operate as intended. So this is the definition of computer organization. The next one is computer design. So computer design is how we design a computer system. So if at all you want to design a computer system, there will be some specifications. So your computer system has to have this set of specifications, like so and so bytes of RAM, so and so GBs of RAM. So all these particular things. So it should have a keyboard, it should have a mouse. So it should have some list of specifications. So every computer has some specifications. So it is formulated as per the specifications. So once these specifications are formulated, so the designer will develop a hardware for the system. So putting together all these hardware pieces in place, so makes the task of a designer easy once the specifications are formulated. So this is also called as computer implementation. So the definition of computer design is, it is concerned with the way the hardware design of a computer. So once these computer specifications are formulated, the designer will choose or develop the hardware or connect this particular hardware, and he will form a working computer system. So this is actually referred to as computer implementation. So the other term for computer design is computer implementation. Next, computer architecture. So this is this architecture is from the standpoint of a user. So when a user is using a computer system, so what is the architecture or what that he sees from the external viewpoint. So this behaves like, so this one, if you are using a computer system, what are the things that we are supposed to just use as the instruction format. Every computer has its own instruction format. So what are the instructions it supports and how to address the memory. So first of all, how much memory is available, how to address each of this each and every word of the memory. So these particular things are dictated by computer architecture. So the computer architecture is concerned with the structure and behavior of the computer as it is seen by the user. So what are the things that a computer architecture has is, it includes the instruction formats, the instruction set, and the techniques for addressing memory. And it is also concerned with the specifications of various modules like processor, memories, and all these particular things. And in general, computer architecture is of two types. So what are the types of computer architecture? So generally we are having two types of architectures. The first type of architecture is what we call it as von Neumann architecture, or the other name for von Neumann architecture is non-embedded architecture. So von Neumann is the name of the scientist who developed this type of computer architecture. So in this von Neumann architecture, all the data and the programs will reside on a single main memory, that is our random access memory. So both data and programs will be residing on single main memory. And right now all the computers, that is the personal computers, in short called as PCs, so that is desktops and laptops, all obey this von Neumann architecture. Our RAM has both data and programs, so that our central processing unit will fetch each and every program instruction by instruction, and it will keep on executing. And the data for these programs is also in the same memory. So that is our von Neumann architecture, which is also called as non-embedded architecture. In contrast to this architecture, we have one more architecture called Harvard architecture. The other name for Harvard architecture is embedded architecture. We use this particular architecture for embedded systems and microcontrollers and all. So what is the difference between these two architectures is, in von Neumann architecture, data and programs reside on same memory, single RAM. But in Harvard architecture, we have separate memory for data and program. So it means that program is saved on some set of memory and your data is stored in the other set of memory. So you'll be having two separate memories. One we call it as program memory and one for the data memory. So which systems obey this Harvard architecture are microcontrollers. So microcontrollers are single chip based computers. So these things, and the other example for Harvard architecture are digital signal processing based computers. This classification of computer architecture is purely based on how you organize your programs and data within the system, that is within your memory. So if you are having only one main memory, it is von Neumann architecture or non-embedded architecture. If you use two separate memories, one for the program and one for the data, we have program memory and data memory, and it is Harvard architecture, or what we call it as embedded architecture. So the examples of embedded architectures are microcontrollers and digital signal processing based computers. In short, digital signal processing computers are DSP based computers. So these two are the examples of Harvard architectures. Thank you.